Around 37 million years before the ancient Egyptians invented fractions, there was a positively prehistoric creature that was half monster pig, half bison, and half guimauve from the never-ending story. While its skull very much resembles that of a giant prehistoric pig species, Entelodon belonged to an entirely different family of even-toed ungulates. Popularized by shows like Walking with Beasts and Prehistoric Predators, as well as games such as Jurassic Park Builder, Entelodonts have earned multiple terrifying nicknames like Hell Pigs, or sometimes even Terminator Pigs. But were they as ferocious as they look? In this video, we'll be looking in detail at the Entelodon genus, how it lived, what it ate, and stick around to find out about their surprising family tree and mysterious demise. To begin with, let's talk about how and when they were first discovered. Entelodon magnus was the first species of this family to be discovered around 1845, around the same time that the genus Elotherium was also described. But this is likely to refer to the same animal. Strictly, Elotherium came first, so if the naming rules are to be honored, it should be the consensus name for the genus. But apparently, Entelodon was just so much cooler that everyone stuck with that. So, the related genera discovered were grouped together in the family Entelodontidae, and this now contains 8 or 9 more of them, all of which were once thought to be some kind of primitive pig. But as we'll discover shortly, the Entelodontidae family has its roots in a completely different group of ungulates. Before we disclose what that is, let's lay out the clues as they stand. First, look at the shape of the thing. It's hardly surprising that the suids were the first animals people imagined when looking at Entelodon. Here's an ungulate with a thick, chunky body, quite slender legs, and pretty gnarly teeth set into a robust skull and held up by a thick, short neck. It also had cheekbones that stuck out, with protrusions that may have looked a bit like those of the warthog, or perhaps supported glands like those found in the giant forest hogs. But there are also quite a lot of differences. For one thing, the legs of Entelodon were long and built for long-distance running, perhaps even at a decent pace. And for another, Entelodon was massive. For reference, the giant forest hog grows up to around 250 kilograms and is just over 2 meters long, around a meter high at the shoulder. The largest of the Entelodon species could have stood 1.7 meters tall, weighed around 600 kilograms, and had a narrow, rather than spatulate snout, compared with modern pigs. This selection of features seems to resemble multiple types of modern mammals, depending on which angle you look at it from. And this has led to some very imaginative artistic impressions of Entelodon. It has neural spines on its neck and upper back that suggest a hump, which perhaps worked like that of a bison, to provide a counterbalancing mass and support for their enormous heads. Some take this to infer a giant, muscular pig with an arched back, others as a plumper creature with a more cylindrical body and chubby face. And while we're at the business end, the teeth also share similarities with a variety of modern animals. There are similarities in its mouth with both pigs and carnivores, including the bone-crushing ability of hyenas. While the skeleton overall shows nothing particularly specialized about this animal, the skull is a different story. It's covered in bony protrusions that are still a bit of a mystery, and when cornered, experts say they may have been contact surfaces for muscle or fatty tissue and could have played a role in display or defense. But since display and defense are more or less the only reasons for all strange features in the animal kingdom, that's just the kind of answer people have to give when they're not allowed to say, "We have no idea." Entelodon had eyes high up on their skulls, and while they had a very small brain, another feature that's distinctly un-pig-like, they had a lot of resources dedicated to their sense of smell. Both of these adaptations could be useful for detecting either predators or prey, but since Entelodon was one of the largest animals around at the time, this does seem to be evidence of the latter. The angle of the eye sockets also suggests binocular vision, which is handy for hunting. The leg bones of Entelodon have some fused components for long-distance running and aren't built for great speed. So this again leaves researchers scratching their heads a bit in terms of how the hell pig fed itself, but the clues are mounting up. And just before we hit you with another big one, it's time for a quick reminder that if you're enjoying this video, it would help the channel tremendously to have you as a subscriber. Likewise, liking this video will help us reach more people and ultimately make it possible for us to create more like it. So please hit those buttons. Now, back to the skull. And there are even more interesting clues to be found in the mouth of Entelodon. The sagittal crest and temporal fossae are both indicators of bite force in animals. The sagittal crest provides surface area for the temporalis muscle, and the temporal fossae are channels for it to pass through. In Entelodon, both of these are huge. Combined with a skull that allows for a lot of leverage, the bite of Entelodon appears to have been similar to that of modern carnivorans, stable and scissor-like. But in most animals, there is a trade-off to having a large temporalis. As bite force becomes stronger and more stable, chewing, that is, moving the jaw from side to side, becomes limited. That's because typically, the larger the temporalis, the less space there is for the masseter muscles. But unlike carnivorans, Entelodons seem to have highly developed masseter muscles too. And this is where the cranial protrusions come in, along with the suggestion of herbivory. Chewing also puts torque on the skull, which needs to be reinforced by cranial bars, as are found in the skulls of Entelodon. But perhaps most excitingly, the mouth of Entelodon could potentially be opened extremely wide. This is signified by a group of tubercles at the back of the skull, thought by some to have been an anchor point for the muscles used to open the jaw. These same tubercles are present on the skulls of hippos. Hippos have a gape of more than 150 degrees, and this is achieved in a similar way. They also have enormous masseter muscles, protruding cheekbones, and very sticky-out teeth. Sound familiar? Finally, the close examinations of wear patterns on the teeth of Entelodons suggest a three-part gobbling experience. Here's how that might play out. Let's say you're unlucky enough to be grabbed by one of these abominations. The first thing that'll happen is the protruding incisors and horrific canines come down with immense pressure and penetrate you in all the worst ways. Next, you're about to find out what it's like to be shredded by the monstrous premolars with an up and down motion, sort of like a meat tenderizer. Finally, you're passed to the back of the mouth and ground up by the masticating action of the molars. Of course, unless you're a woody plant, you're probably too soft to require this thorough of a processing, and you're more likely to have been swallowed whole or in chunks after the second stage. But what this means is that there was very likely more than meat in this animal's diet. So, what does the hell pig have for breakfast? It wasn't humans because they hadn't been invented yet. In fact, this terror roamed Europe around the time that apes and monkeys were branching off from one another. It's quite possible that, had our ancestors come down from the trees in Europe instead of Africa, they would have promptly returned to the canopy when they saw Entelodon, and we would never have existed. But meat was most likely a big part of the Entelodon diet. Whether this was hunted or scavenged is still a mystery that's up for grabs. But the flat bunodont molars at the back of the mouth suggest a very generalized diet that would have included plants too. For example, both pigs and humans share this characteristic, and they'll eat anything. The enormous bite force and capable chewing ability suggest a competent processor of woody or otherwise fibrous vegetation. The narrow snout suggests a browser rather than a grazer, as does the lack of ridged teeth for shredding grass that you typically see in grazers. Roots, nuts, bark, and probably a substantial amount of carrion would have made up the bulk of this animal's diet. And with such a generalist nature, it's unlikely to have needed to be a top predator when being an opportunistic omnivore covers all bases. Patterns of wear also reflect those found in bone-crunching hyenas. But the most unequivocal evidence of carnivory in Entelodon are all the tooth marks in the fossils of other animals they shared their ecosystem with. The Entelodonts as a whole spanned much of the northern hemisphere, but Entelodon was one of just 4 species found across Eurasia, and this one would have been mostly restricted to Europe. Fossils have also been found as far east as China and Japan, but they appear to be less common. As scary as they would have been, Entelodon were far from the only dangerous animals around at the time, sharing their space as they did with ancient carnivorans like the bear dogs, amphicyonids, who moved into Europe from North America around 45 million years ago, and the hyenodonts, who evolved in Europe and became some of the most dominant carnivores of the Paleogene. But perhaps the most frightening competition came from its own kind. The protruding teeth, the enormous gape and the various cranial protrusions may all combine to form a head that's well built for intraspecies rivalries. Fossils of other genera in the family found in North America show plenty of signs of this kind of behavior, with healed puncture wounds and other bite marks attributed to conspecifics. That's almost it for this video, but having laid out all the clues, it's only fair we conclude by talking about the revelations that came out around 2008 that the hell pig was not at all what it seemed. Pigs are already intimidating animals, smart, fearless, and able to bite through the delicate calcified form of a human skeleton, like a knife through butter. And considering what we do to them, we'd absolutely deserve it. So the thought of a 2-meter-tall prehistoric swine that could run down a hapless backpacker and chew it in half is terrifyingly feasible. But the reality of this animal's diet wasn't likely to be quite as exciting. Furthermore, Entelodon wasn't even a real pig. But not all developments are disappointing. This one is actually pretty cool. By analyzing an unprecedented number of samples, Entelodons have been more recently placed in the crown group Cetaceomorpha, along with hippos and cetaceans, making Entelodon a closer relation to whales than pigs, with hippos being a sort of contemporary analogue of the transitional species between land-based artiodactyls and cetaceans. This also lends credence to some of the ideas that Entelodon might not have been quite as lean as it's often depicted. Still, all evidence points towards an animal whose position in the ecosystem was far more similar to that of a large pig than a whale. We may never know what Entelodon looked like, since it went extinct somewhere between 19 and 16 million years ago, possibly as a result of the success of far more specialized animals like the Hyenodonts and the Carnids, who've remained to this day as some of the most successful generalists around. Or perhaps, almost ironically, the Suids, whose adaptability, intelligence, and readiness to hybridize saw them rise quickly to prominence from their Asian origins and rampage successfully into ecosystems all over the world, right around the time hell pigs started to disappear. Thanks for watching. See you next time.